Hi. So I'm a software engineer. I'm a software engineer at Facebook. I work in the network platform group. We work on defining the abstractions and the framework necessary for modeling and managing our network. So command execution on devices is a critical component of managing devices at Facebook. The command execution at the scale of Facebook creates a lot of unique challenges, and we are going to talk about some of those challenges. We are going to talk about our solution for those problems. So we are going to talk about the FBNet command runner service that we had created. We'll cover these APIs and how to use those APIs to run commands on the devices. And finally, we are going to set up an FCS service from scratch with a very small changes needed to adapt it to any setup. So Facebook Global Network has tens of thousands of network devices. And we need to be able to run CLI commands on those devices for provisioning, monitoring, and deployment. Running commands on those devices at Facebook scale creates a lot of challenges. So how do you start running commands? Right? So you start with having an expect script or something which logs into the device, does some prompt matching, runs the command, and gives you back the output. It works on a small scale, but as you start to grow, you have multiple vendors, you have to match multiple prompts, there are different setup commands, and it becomes difficult to manage. And more than that, these scripts are difficult to scale. Running a script on multiple devices is slow, and it doesn't even work at Facebook scale. These scripts become the bottlenecks, leading us to slow down our deployments and slow down our monitoring. You can only achieve a limited amount of parallelism with these scripts. On top of the vendors and the scale, you have to support multiple sessions to the devices. Sometimes you have to go over the console when you're configuring your devices. And there are other sessions based on the vendor that we need to support. So we were looking for a solution to help address this problem better. So what we needed was a seamless way to be able to run command on any device in our network. And we wanted it to run at scale. Okay. We didn't want our scripts to have to deal with connection management, prompt processing, right? And in doing so, allow them to scale along with the network. So for this, we created our FBNet command runner service. So this service defines a very simple yet powerful APIs. There are only 5 basic APIs that we expose. These APIs allow you to run command on any device in our network without needing to worry about which vendor it is from. You still need to figure out which command to run based on the device type, but you don't have to do the connection management, and you don't have to worry about matching the prompts and dealing with those intricacies. The only information that this service needs is the vendor information, which is, how do I run a command for a particular vendor? I need to know the prompt regexes or any set of setup commands that I have for initializing the initial connection. The service also needs to know about your devices. What devices do you have in your network? So it allows you to interface it to your backend database, which gives it the source of truth about the different devices, their names, their vendor, their IP address information. And this is used by the command runner device to actually run the commands on the actual devices, instead of doing a DNS or name lookup. So in short, the FBNet command runner is a scalable thrift service. It allows us to run tens of thousands of commands on our network devices. It frees up the scripts to focus more on the business logic. You just need to figure out which commands do you need to run, and you don't have to worry about how to run them and how to scale them. And it being a thrift service, it frees you up to choose any language for your clients. So you can have your automation scripts written in Python, Java, Go, or C++, whatever you wish to use. The service itself is written in Python 3 and uses the modern async I/O framework. It is open sourced. You can download it, configure it, and use it, and hopefully will help you scale. So now we'll briefly go over those APIs and see how you can use those APIs to actually interact with the devices. The run is the simplest simplest of the APIs. It allows you to run a single or a set of commands on a single device. Right? So using this, all you need to do is specify a command and the device on which you want to run that command. So just a small animation. So the client wants to run show version on device B. He sends the command to the FCS service. The service runs it on the device and ships the result back to the user. The bulk run is another API. This is one of the more powerful APIs. It allows you to run commands on multiple devices in parallel. So with a single API call to this FCS service, you can run commands on thousands of your devices and get the results back. You don't have to worry about creating threads and managing multiple connections to those devices. All you need to do is give us a list of commands, a list of devices, and the commands that you want to run on those devices. So just to show, so you have a bulk run call saying, okay, on these 3 ABC devices, run these commands. The FCR will open connections to all these devices in parallel and start running these commands in parallel. It will collect all the responses, and once it has all the responses, it will ship the responses back to the client. So with a single call, you can potentially address thousands of your devices. In addition, so for the large bulk run calls, it can do a load balancing across different instances of FCS service. So if you, let's say, want to run commands on thousands of devices, it will break that down into smaller pieces of, let's say, 100 or 50 devices each, and will spread it around to other FCR instances that are running. These instances will run those commands in parallel and collect the responses, send it to the originating service, and the originating service will collate all the responses and send it back to the client. In addition, we have some interactive APIs. These APIs allow you to open a persistent connection to the device. These are typically needed or useful when you are trying to do some interactive application, where you need to run multiple commands on the device in succession, but don't necessarily want to send all of them in one shot. You also need these need to use these APIs if you want to persist the session state on the device. So you're trying to, let's say, configure a device and configure it interactively. You don't want the connection to go down, because once the connection goes down, you may lose the config that you have already created. These APIs are also simple to use. You open a session to a device using the Open Session API. It connects to the device and sends a session ID back to the user. Now you can, using this session information, you can run multiple commands. And the FCS service will use the same connection to run commands on those devices. As long as that session is open, you can keep running any command on that. And finally, you have closed session to terminate that session that you have. Now, installation. Installation is straightforward. You need to clone our GitHub repository and just use the normal Python package managers to install all the needed packages. Using these APIs in code. So what do I need to use or run commands using these APIs? So all you need for you to call an API is a Thrift client to the FCS service. And once you have that client, you can simply call the API on that client. Right? And you will get back the result that the service sends back after executing those commands. Right? So here we are running some commands using some secure passwords. Bolton is also similarly simple. All it requires is a map from a set of devices to a set of commands. Okay? So once you create that, again, it's the same thing. You get a client and use that client to pass this request to the FCS service, and you get back the response for all the, a map from each device to the result of those commands. Here, this thing ran the commands on both two devices and shows you a set of results that we got from those devices. So this bulk run is actually very useful. So using this, for example, we can configure a whole set of devices in a single shot. So once you have, let's say, configuration already available, you can use it to push that configuration onto your devices. So here, in this example, we have a sample configuration listing just for one device, but let's say there are other devices also which have which have their own configuration stored in some file. And all we have to do is load this config, create a device to config mapping, and use bulk run to push the config to the device. So with this small piece of code, now I have the ability to scale and push the configs to a large number of devices. So here, just to show, yeah, the config was pushed, and OSPF got configured and is up. We can run trace route between two hosts in the sample setup. So, okay, so the FCS service is, okay, the APIs are easy to use, but what does it need to actually for me to set up the service? Right? So it's easy to adapt the FCS service for your setup. All we need is the vendor information about what vendors you have in your network and how do I run the commands on those vendors, and the device information. What is the addresses of devices? What are the vendors of your devices? So for each vendor, we need a vendor name, what session type you want to use to run commands on the vendor, what are the setup commands for initialization of the connection. These typically include the commands to set the terminal settings of your session, and prompt regexes that the FCS service should match when it is running those commands. So for this example, we are creating a sample vendor called for Quagga's daemon that is running, and these are the options that I need to be able to run commands on the Quagga's VTY SH. So you specify this vendor config in a JSON file. Here we have the two sample vendors that we have created. So on our GitHub repository, we now have a sample vendor config file that has the sample initial config for some of the popular vendors that we have out there. So you can use that to start playing with the service. Other information that we need is the device information. We need the name to address and vendor mapping for those devices. Here, typically these will be in some backend databases. For this demo, the database is my JSON file. So we are going to specify our list of devices using this JSON file. So now loading this, so how do I load this or interface with your backend database for this service? So to interface for the backend database, you need to just implement a device database class and implement the method to fetch the device data from your backend service. So here you will typically implement connection to your database server or database and fetch your device information from there. In this example, we are just going to load the device information directly from our JSON file that we have. And that's about it. All you need to do is now define an FCS Service Class, which ties all these things together. So you instantiate a device vendor class, device DB class, and your service is ready to go. So with these small changes, you have a fully operational service that you can use to run commands on your devices. Now, as you start using this service, and as you start running commands using this service, at some point, a single instance will not be sufficient for you to run commands on all your devices. So at this point, you will need to scale your service. So to scaling the service is also very easy. All you need to do is create more instances. Right? So you spawn off more instances of the service and start load balancing between these instances. Right? So that way, the service can grow as your network keeps growing. So to summarize, the FCS service allows us to run commands at Facebook scale. We are continuously running thousands of commands on our network devices and collecting information from them. It allows us to keep our network operational and react to changes happening in the network in a timely manner. The APIs are powerful and easy to use. You can scale your scripts. You can easily scale your scripts using these APIs without needing to worry about creating threads, managing connections, running out of file descriptors, things like that. The service itself is easy to set up, and it is easy to scale. And we have open sourced this service, and it is out there on GitHub. You guys should go and try it out, and hopefully it will help you scale your networks as it has helped us scale our network. Yeah, that's all I had. Any questions, comments?
Matt Petak, Yahoo. That looks really awesome. Thank you for sharing this. One thing I noticed is that this is a very optimistic presentation. You return a list of here's all the commands on the devices I ran and their wonderful output. If you give it a list of 10,000 devices to run a command on, and 173 of them fail, do you have to simply parse through all 10,000 command results to try to spot which ones don't look right to see which ones fail? Or does it give you back something useful like, here's all the boxes I couldn't reach or couldn't execute the command
Yes, right. So what you get back is a command results struct for each of those commands that you try to run. For the devices to which you are not able to connect, you will actually get a status. So command result has a status field in there which says, okay, command failed due to this reason.
So you'll get a nice, easy to spot status result code back. So I don't
Yes,
have to, okay.
yes, it will give you the exception that it encountered back to you so that you can see why it actually failed.
Got it. Thank you. Otherwise, you're back to, here's another mess of parsing you get to do. Good luck. All right, thank you.
Thank you.
Sorry, I'm so slow to the mic. Peter Britton from MetaSwitch. It was a very clear description, really understood it. Didn't quite get how the heterogeneous bulk operation would work. So you've got the facility to break things down so you understand that you can run certain commands and parse stuff out based on the prompt. Mm-hmm. But what happens when you say, I've now got 10,000 devices, 5,000 of them are Cisco, 3,000 of them are Juniper or whatever, and I want to run something to, I don't know, set up a particular config, and it's completely different on both. Mm-hmm. So how can you do that in one bulk operation, or is that two bulk operations, or
yes.
broke down like that?
So you can do that in one bulk operation. So the thing to make clear is that it's a service that allows you to run commands, but you still have to figure out what commands to run. So that is another layer on top of the service where, for example, for Juniper, you will figure out, okay, to get the route information, I have to show IP route forwarding, whereas for Cisco, I'll do show IP route. And once you have that mapping, that, okay, this is the command that I want to run on this device, you can do that in one bulk call operation.
So where do you define that in your data structures?
Let me go back, if I can. Yeah, so for example, this, right? There are two different commands that I am running on device A and C, right? So show route forwarding table and show route, right? And these commands have been determined based on the type of device I am going to run it on, right? So you still have to know what command you want to run, right? That is determined by the sort of a layer above the FCR, right? So FCR allows you to run that once you know what commands you want to run, it can allow you to run it at scale. Did I make?
Okay, I think I get that. So, but A and B and C are an individual device. So you're picking for every device. I then know, or is it a device type?
So A and B and C are individual devices. So you want to tell that on this device, I want to run this command.
Right. Got
Right?
it.
So it's not the device type. It's saying, okay, this is the device type. So the service itself is vendor agnostic. It doesn't care about the vendor.
Yeah.
It says, oh, whatever you give me, I'll pass it on to the device. So if you send a Cisco command to a Juniper box, it will try to run it on a Juniper box.
Okay, I think I've got it now. Thank you.
Okay, thank you.
Hello. Yeah, I have one question on the source code. I looked at the GitHub. You have a license clause where you have a patent clause which allows Facebook to do a counter lawsuit. I think that one is little, that makes people who using the code little uncomfortable. Do you plan to remove the patent clause from the source code?
Yeah, unfortunately, I cannot answer that question. So for that, we have to talk to the IP and the legal team. They are looking at this issue and actively, I think, working on that, how we can resolve this problem of that patent clause that you are referring to. But it's beyond me. I will not be able to answer your question.
Yeah, just wanted to raise the point. Thank you.
Sure, thank you.
Do we have any more questions in the room? All right, then. Thank you very much.
Thank you. Thank you, everyone.